Just a short PowerPoint here. And my name is Peter Emanuelsson in Swedish and Peter Emanuelsson in English, not so different. And now I changed my slide. Can you see this one now? I just want to say that MagiCAD is an MEP software, mechanical, electrical, plumbing, and here is just a very small example of how many objects you can have. This is a refurbish project in Finland. It's a hospital. The renovation is 36,000 square meters, and someone in this project wanted to know how many objects different participants in this project had. So they calculated it, and the architect close to 31,000 objects, structural 85,000, and all MEP together close to 470,000 different objects. And so the MEP part, we have really mass of products to install in a building. And then you can also see that what electrical stuff, 70,000, ventilation, 86,000, and so on. But now I don't know if structural have counting any rebar. I don't know about that. Maybe it's just slabs. I don't know, but it could be more if they counted rebars. But anyway, so MEP, of course, are really very important here. We need, of course, to take care of this 470,000 objects. Yeah, you should have a good software to help you out with this. And just to give you a brief, how many things are installed in a project like. Just short also about me, and this here you can answer any question. I know myself very well. Yeah, Peter, as I mentioned, my nickname is also P2. I was working many years ago in the capital of Sweden, Stockholm, and we were 3 Peters at the same office. So we were P1, P2, and P3. I was the second Peter joining that company. And I don't know if you have seen this children TV show. It's called Bananas in Pyjamas. We had it here, at least in Sweden. I think it's from Australia or somewhere. But the Bananas was called B1 and B2. I'm 48 years. I think I'm still feeling rather young. But Roger he's young. I'm old, but at least I feel it. I live in middle part of Sweden. It's far north. We have spring here. I still have snow on my yard. It went down to minus 32 degrees Celsius this winter. And in the best summer day, best, and maybe one day in this summer, I'm going to have plus 30 degrees. So and MagiCAD is from this area, and so we need, of course, to take care of our buildings rather well, because it's the delta T is like 6 degrees from coldest day to hottest day. So we have very thick walls. We put very much insulation into our buildings. So we need to, of course, to ventilate them. We need to cool them down, and of course, in wintertime we need to have heating. So when we do all of this with MagiCAD, and in wintertime, the sun nearly doesn't got up. In northern part of Sweden, from December to I think it's mid-February, the sun doesn't rise because it's so up north. It's above the polar circle. So of course we need to have electric light in this. So MagiCAD is a super software here too, because we're doing ventilation, heating, cooling, electrical. And of course we need water also, so we have of course domestic water also. I started to work with MagiCAD 98, so I've been here now for over 20 years. I'm still like it very much. I travel around. Yeah, before the Corona, I was traveling around a lot. Been to Malaysia, I think it's 3 or 4 times. Went there to train Rajesh and to meet my colleagues over there. But now it was a couple of years ago I was there last time. But now also here in Sweden, maybe you have noticed that in Corona times in Sweden, we are doing what other people doesn't do. I'm not in quarantine. I can go for shopping. I can go. We have you can meet people nowadays if you are less than 50. If you are 51, no, that's not allowed. But if you're under 50, you can still meet people. So now we're doing everything also here remote and via internet. But when I'm not traveling, I already have my home office all the time. In 20 years, I have my home office. So when I'm not out traveling, I have my home office. And here I have two boys. They're now 20 and 17. And I have one wife I have typed there. But I don't know. I don't remember just how it was in Malaysia, if you could like stay together but not getting married.
That's
I think you can.
That's fine.
But in Sweden you can, and we call it like live together. So you can buy a house together, you can have kids together, but you don't need to get married. But if you go to Middle East, for example, this is really hard to explain. So when I go abroad, I'm always lying that I have one wife, and I hope she's going to be my wife someday. Ice hockey, I don't think you know what ice hockey is, or maybe you do. Swedes are very good in ice hockey. I do it on my spare time. I like fishing in summertime. And of course, MagiCAD is a part of my hobby also. And just to show you where I am, sorry now, the Southeast Asia is not on this map, but anyway, Europe and Sweden now. So Swedish capital here is Stockholm. I live like 600 kilometers north of it. If you don't know anything about Sweden, we have different Corona rules. Maybe that we have IKEA. We have had many things. Volvo was a Swedish, but now it's Chinese. Sony Ericsson phones. Maybe some of you have used Ericsson phones. That we have had. We still have Nobel Prize, IKEA, H&M, Zlatan, if you like football. That's Sweden. And last here now, just a picture of my house. So I'm standing inside this window now. It's not. This is a little bit more in the winter time, so I don't have this much snow today. But anyway, okay. Now we go for demonstrating, and it was of course good that was the most percentage of usage was AutoCAD, and that's why I start to show MagiCAD for Revit. We have MagiCAD for Revit on two platforms. AutoCAD, in AutoCAD we released the first version 1998. So of course we have developed the software very long. We released the first MagiCAD for Revit version. It also have been out for a long time, 2009. So 12 years it have been out. And users here in the Nordics are still more into AutoCAD also, but the Revit part is growing rather rapidly. So this, or the half year 2019, the second half, we trained more people on MagiCAD for Revit than MagiCAD for AutoCAD, but it was not so huge different. So we are still selling AutoCAD, we're still selling Revit. But we start here now with, and I need to go also to just show, and you see my Revit screen now because I have two screens. So I know that you see the right one, or do you see, Rajesh, do you see my Revit screen, or do you see?
Yes, we can see Revit.
Great. A normal Revit project, and if you haven't heard about or used Revit, it's a CAD software developed by Autodesk. Same developer as you have developed AutoCAD. The big difference is that you have just one file. You draw everything in just one file. So if you have a 5-story building, you don't have 5 ventilation drawings, you have 5 piping drawing. You have everything in just one file. And then you check different views from that database. And so if I go now for my ventilation view, I go here and here, now I can see all my ventilation. If I go for a piping view, I can see all, but everything are in the same file. And this is of course, if I then move, for example, a shaft, if I just start to draw a duct here, I go for ventilation now and I go for a duct. Now I have used the Swedish template, so maybe system names and the naming for ducts are a little bit different. We have also made localizations for Malaysia also. So Rajesh is a part of that team to do localizations for both AutoCAD and Revit. But I'm drawing now a duct on my supply system. I said it should be 500 size. The center level, the top level, or the bottom level. And if I now change, I want to have the bottom elevation 2 meters above the floor. It's not so hard to calculate the top elevation. And of course, if I put insulation to this duct, then of course, if I type in something, you see the top elevation of the insulation on that duct. But I maybe going back to this dialogue a little bit after, but now I was just going to draw a duct here. And of course, you can draw inside the house, but I'm going to draw a little bit outside, because if we go for 3D, if we are inside the house, you have a false ceiling, you have walls, you have stuff in the way, so it can be hard to see. So that's why I'm drawing now outside here. And let's now go up to, say, 16 meters. Okay. And I continue to draw. So if you now go for my 3D view here, we can go for this one. We can close this one now. And we go, and I'm tiling the views now, so I can see the 3D view, and I can see my 2D view. Where did I draw my duct? Here it is. And maybe I've turned the ducts off. Yes. And what to decide what to see in AutoCAD, maybe you turn on or off layers. And Revit, where you do it kind of the same, but it's called that we use something called visibility graphics. And as you can see here now in my 3D view, I have turned off. I don't see ducts, so I turn on my ducts here now. And I also want to see duct fittings and duct accessories, and we say okay. Okay, so here we can see now the duct. And if I now also open the third floor, like this, and we tile them again. So here I have my third floor. It's called V57300, and I have just a duct going through it. And here I have my 3D view. If I now go to my first floor here, and if I select the shaft here, if I now move it, you can see that it's updating in all the views. If I have been using AutoCAD, then I have, in AutoCAD, you have all the stuff in ventilation floor 1, ventilation floor 2, and of course the shafts are not connected. Then of course, if I move a shaft in some floor, of course I have to open the floor below and move after. Here it's together. So that's one of the biggest thing between Revit and AutoCAD, that you have everything in one file, and if you do something in one floor, it's going to adjust also in other floors. Yes, let's continue here now to I think we should start with some common tools, because when you install MagiCAD, you get some extra tabs inside your Revit. So I have one MagiCAD Common, and Common means that this is features that we use for both, or for all of for ventilation, for piping, for electrical. For example, provision for buildworks. If I need, of course, you need, when you draw, you just draw your duct, your pipes, your cable trays, and you don't need to care about the walls. It's like the duct are like Wi-Fi, you can just go through a wall. But of course, in real life, yeah, you need to cut a hole, because the wall is maybe built of concrete, and you can't just, how easy, it's very easy in CAD or in Revit here to go through something. But in real life, of course, we need to cut a hole in it. Here I have drawn a wall. This wall is now in my model. Normally, it's a link or XREF if we talk AutoCAD. And we can also do this provision for voids also for linked files, or in AutoCAD in XREF. But I'm going to show it here now. To this Revit project, We also connect something we call a data set. And in the data set, you can put in what data you need to have in your project. And here I have already made holes, and it's no problem. I don't know how you do it in real life, but here I can just select a hole and then delete it. And I didn't want to delete the wall. I wanted to delete the void like that, because I have already done this. Yes, do I have a hole here also? Yes, I have a very tight one. The wall again, sorry. Delete, like this. This data set, and I'm going to modify it a little bit. What is a data set? Yeah, in the data set, you put all the stuff you want to use in your project. You put terminals, you put silencers, you put which kind of products you want to use. You also put in, if you have a duct here, how much bigger should the hole be? Okay, so let's start to check this a little bit. So if for ventilation here now, I can create my different duct series I want to use. I can put in insulation series. And of course, if I have used the Malaysia template here now, of course, Rajesh have put in here now, for example, insulation series names after your local standard. This is what we provide in Sweden. So now I'm for insulation for pipes, and here we do like this, that because you have the insulation, and different pipe sizes should have different thickness of insulation. So if I use this S1A, then it says that if the pipe size is between 0 and 20, it's going to put 50 millimeters of insulation to that pipe. If I do some sizing, or if I manually change, and the pipe get bigger, so if it's between 20 and 50, I'm going to have 60 millimeters. So the only thing I have to do is put the right series to the pipe, and if the pipe growing or shrinking, then MagiCAD is going to change the thickness after this table. So this is information that we need in the project. And of course, how do you want to size your ducts, or how do you want to size your pipes? I show it for it's kind of the same. I can select here. Do you want to go after just some Pascal per meter? So for all ducts sizes up to 9,999, I don't want to use the velocity in this case. I want to use the pressure drop. But I can also create that, okay, like as with the pipe insulation, with this one, I allow the area of the duct is between 160 and 0, or between 0 and 160, I should say. Then I want to maximum have 4 meters per second. And so I can now here create my own sizing methods. And what's happening if I go for the 1 Pascal per meter, this one, if I'm running the sizing, and if the pressure drop in my duct are above 1 Pascal per meter, then it's going to change the size on the duct, and then, okay, it needs to be this size, and then it's check, okay, is it under 1 Pascal per meter? Yes, it is. So it can check if I have drawn a too big duct. Maybe I have 0.5 Pascal per meter in the duct, then it's going to shrink it and make it smaller and optimize, okay, to get close to 1 Pascal per meter, it can go also both up and downwards with this. And of course, inside here, we can also, for example, supply air terminals. Here I can now select which kind of products I want to use. If I'm checking this one, okay, here we have an air terminal from Svegon. If I need to have a new one, of course, I can now say, okay, to this project, I want to have one more air terminal. Then we have product databases. So now I go for my browser here. And this is the same how it's work also in AutoCAD side. So we have exactly the same method in AutoCAD. You select which product you want to use. And let's say that I want to have maybe, yeah, let's see, I go for trucks. I want to have trucks air terminals here, air diffusers or what is it here. We just select one thing here. We take this one. No, that was boring. We go for air grills maybe, or yeah. So here we have, you can see it. We can see the measurement of it. We can see, yeah. And in this, it was one question if you use BIM software, or I thought it was in the poll, and BIM, Building Information Modeling. For here, a ventilation guy, at least an engineer, the information, the I in BIM, pressure drop diagrams. If I don't have this one, and the red curves are, of course, how much sound this product are generating. For ventilation engineer, of course, we need to do some calculations. Without pressure drop diagrams, you can't do balancing, because when we are doing the balancing, we are going to see an operation point. So we can give this to the contractor that are going to adjust this ventilation network, the system, because inside this product you have a damper. It's fully open, fully closed, and you have to adjust it. And that information is crucial for engineers that want to do calculations. Of course, sound curves. If you don't have sound curves, you can't do sound calculations. Into a ventilation system, you have a fan, air handling unit. Of course, that machine produces sound that's go into your duct network, and then you can see. I think you have noticed, yeah, maybe not now, but when you are at the office, hotel, or at night, when the air handling unit shuts off, you can feel it, how it's getting suddenly really quiet. And of course, we can calculate how much, and different types of spaces or rooms have different rules. You know, if you are in a hospital or a library, yeah, it should be rather quiet. But if you are, sorry, I have to. If you are at a discotheque or a bar, listening to drinking beer and listening to ABBA music. ABBA was also from Sweden. Sorry, that's my, and Swedish House Mafia also is also from Sweden. Playing that music really loud, then of course doesn't matter how much sound that are coming from ventilation system. Yeah, so here we can, of course, and if I now go to, this was a air handling supply air terminal. If we do the same and scroll down here and we go for piping, yeah, maybe also you want to calculate your cooling system. You have some things that cool down your building, and of course, if you go for a zone valve, for example, yeah, 3D object. Yeah, of course, 3D is a part of BIM, because if it's just flat, just a, but out at site, the symbol here, and of course, different countries have different symbols. Here in Europe, we were really, we thought that we should be happy when we went into the European Union, because we thought that, okay, then we can have just one symbol library called EU. But no, everyone is still using the same symbols, the localized symbols in different countries. But of course, this is of course needed. So we provide, and when I'm using this valve, when I put it out, MagiCAD combines, so I can choose myself. If I go to 1D, I'm going to see the pipe with center line, and I can see the pipe with a symbol, and that's what I'm going to plot and give out to the site, to contractor. But if I go to 3D, yeah, of course I can see the 3D model. And of course, properties for this one, also for piping persons. Diagrams, information here again, because this is a zone valve. Have to adjust how much cold water are going to go to that machine to get the right climate in your office. So of course you can tweak this valve, and when we're doing the balancing in cooling, Of course, we are going to have the operation point, the kV value, and of course you can print out a list that in Office 122 you have a zone valve, the kV value is something, and it's very easy to adjust that valve to get the right flow out from that machine that give you nice climate in your and I don't know if it was an electrical guys, but of course it's inside here also. So we go down in this data set. Of course, drainage, same thing. If it's domestic water or if it's sewage, electrical, same thing. Here I'm going to give you a small example of symbols. This emergency exit luminary. Of course, this 3D object, it's normally the same all over. But this is the Swedish symbol that you should run to the left if you get into fire. So if you come to Sweden, don't go into fire because you'd never find the way out. Because if you're seeing on the drawing, but of course in the real world we have this, of course. But just to our closest neighbor, we have the most border to, it's Norway. They draw exactly the same thing with this symbol. It's, yeah, and of course we have Malaysian symbols, Singaporean symbols, and that's rather good. The UK, maybe it was not so nice of them to colonize so many countries, but one thing for us is rather good because rather many countries are using the same symbol libraries as the UK guys. So less work for us too. And we continue also a little bit here. We also have schematics inside. So here we can now say, okay, I want to have some schematics for piping. Maybe I want to have some shunts, and of course here we can provide. So I have my symbol libraries for also for doing schematic drawings. And in the schematics, if I want to have same information in my model as I have in my schematics, I can connect a symbol in the schematics to a valve in my model and transfer data. Do you want to have the kV value in your model and in your schematics? Yes, you can. We can link objects and transfer data between the objects. And was very long talk about this data set. I was talking about provision for voids to making holes in walls. And down here we have, of course, provision for buildworks openings, settings. So here I can now set, and we have kind of the same in AutoCAD also, but we don't. It's in Revit you always get 3D walls from structural and from architect. In AutoCAD, not as often. It's rather often that HVAC or electrical engineers or designers, drafters get flat architect drawing or flat structure drawing in AutoCAD. And of course, to make this holes, you have to have a 3D object to go through. And here I can now set that, okay, if I have a duct, how much bigger than the duct should the hole be? This variable H4, if I get two holes closer than H4, then MagiCAD are going to suggest to make one big hole instead of two holes. We can also say that don't do any holes with pipes smaller than 20, for example, because maybe if you have a 20 pipe size, maybe contractor just take his Hilti machine and drill the hole himself. But if it's big holes, you need to have a big machine to saw or drill the hole. So this is the settings. We can have a timestamp on this. We can also put symbols because in your 2D drawings, I don't know your symbols, but at least here in my area, we have in your 2D drawings, you can have a symbol that's present in 2D. So you can see, okay, here we have a horizontal hole. If you have a slab, a floor slab or roof slab, if you go vertical, you can have different symbols. You can also see them in a 2D drawing. Okay, so now I just run with this. What we don't do today, we don't, and maybe we are going to do it in future, but not today. It doesn't matter which kind of wall this is. Is it marble or is it concrete? Is it gypsum wall or no? It doesn't matter. The size of the hole are still the same. And in real world, it can be that, okay, if you have a concrete wall, you wanted to have a hole smaller or bigger, or if you have a gypsum wall or light wall. Today, we doesn't do any difference with kind of wall. But let's say now that I have put the settings in and I now want to create some provisions. You can do it manually, boring, but you can. I do it automatically. I'm going to select object. Now I take from current view, and of course can be now. I have just linked in now the architect file, but I can of course, and maybe it can be so that architect they don't draw the heavy walls. So maybe I should go and do the voids to the structural model because they do the concrete walls. But I do it everywhere now. We say just okay. And here now I have a new voids. And do you want to create? And here we can now skip. We can say show, so we can then zoom and find them very easily. But I say just okay now. Okay, what's happened? Yeah, now it's put in now a void here, and if I zoom in here, you can see that it's very hard to see if I have it in this view. So let's say we go for some, there we have it, and maybe go for thin lines. So here I have now the void, and MEP engineer or designer, we can't decide ourselves, or at least not here, that okay, it's okay to drill a hole in this wall. Here we have to ask for permission that it's a structural guy that have to say that okay, you can drill a hole. The building are not going to collapse if you drill this hole. So this information I'm going to send now to the structural guy or architect, and they have to check now with their calculations. Does it happen anything if we do these holes? Hopefully not. And it can be rather many. And also over here I have two pipes, and now this H4 parameter was less than something, and then MagiCAD decided to make one big hole, rectangular hole here instead of two small circular ones. This information I now sent to the structural guys or girls. If they are smart, and hopefully they know, they have installed a free software that we have providing called Manage Openings. Here we can now manage this. So here we can also find out. So you just they link your voids into their model, and now they can go here and see. Okay, here we can now say, okay, this void, do you accept it? Do you reject it? Or what do you do? Do you want to type in a note there, move 5 millimeters to left or something? And then I can save this report, not I, structural guy, save it and send it to me. It's just a text file. And then I load it, and then I can see, okay, I can really very easily find my own void, and I can see the comments here that I should move it, and I do. And then, yeah, but if now structural guy are happy with this, then we can just like control or shift click on this one. I need to have access to the wall. You see the host. To make the provision, of course, I can use a link file, but to really actually physically cut the hole, I need to have access to that. And MEP guys, we don't have access to walls. That's the architect or structure, so they have to do this. But now we say create openings. Okay, so if I now say okay, we don't want to save this report, and if I now turn on my shade here, and of course now we can now see that we physically have made holes in this wall. And maybe I could check from this. And of course this is something of course you do. We don't have Wi-Fi ducts yet, or Wi-Fi cable trays or Wi-Fi. We need to go through, and we need, of course, not every building have open landscape. We still have walls to pass. This feature we also have in AutoCAD side, but as I mentioned that sometimes you don't get the 3D wall. We need that too. And of course, if I had now gone through a floor slab or roof slab, of course, we can also do holes in them. Okay, let's now just go for, yeah, we take this one. We go over here. Or maybe my building a little bit. We take maybe that one. We take. No, that's the second floor. That one we take. Okay, this one I now want to. Why have I put it yellow? Maybe I have used some view template to show something here. Yeah, I have some. Take this away. Okay. If I normally people ask if I move something here, does the void follow? No, of course not. It shouldn't, because if I need to move this duct, of course, if I select the void, but normally it's of course a new. We have to check this again. I can't move any holes without any contact with the structure guys. Let's now just collisions. Of course, now I want to have a collision here to show you what a fancy tool we have to avoid collisions. But so now I'm going to make some collisions by mistake, or not, it's not mistake, but I'm going to draw a duct here. But first, we're going to, of course, it's also a common tool. Clash, so we were here now, a common tool, and of course, provision for voids, cable trays, pipes, ducts, yes. Clash settings, yeah, everyone is going to have a collision. Look, now I can set here, if I want to do a check, and I can be rather exact here. I can say for ventilation, okay, let's say all ducts, and now I'm just going to check with myself. So I check now with ducts and ducts. But of course, if needed, ducts to architect furniture. Yeah, but why? Yeah, I don't know, but maybe you guys have some strange thing to. We don't want to have collision with furniture, so of course you can, if needed, you can do it, and you can of course do now also to the architect file, to the structural files, and if I now, maybe I don't do the electrical stuff here. Maybe it's other consultants that do the electrical part. So of course they have drawn cable trays. And then of course I can link in Revit, Xref in AutoCAD. I can link the electrical cable trace files into and I can also make collision check to link stuff. But now I just go for ducts and ducts, and of course here I can now save this if I have a configuration. I can name it duct to duct, duct to pipe, because it can be time consuming here to click and click and click to fill in everything. So you can also save them. I want to put on real-time clash on. It means that when I'm drawing, it's online going to check if I have a collision. Okay, Here I put, if I have a hard clash, then I'm going to have a red color. If I have a soft clash, then I'm having yellow. And now I'm just putting here 50 millimeter for ducts. I say clearance zone for pipe 50 millimeters. And I say ignore pipes smaller than 20 because they are so easy to bend. And now, if I'm a ventilation guy now, but I still, if you ask electrical guys, they say, okay, you can't get closer than 500 mils around my cable tray. But of course, I don't know. I'm ventilation, so I say 50 millimeters. So this 50 millimeters now all over, it's for the yellow one, for soft clash. So if I have something, duct, pipe, cable tray, and I have 49 millimeters between them, then I'm going to have a yellow color. So soft. Okay, this is my settings. I run just okay. And if I now start to draw a duct, and there were a note that if you want to have this online, it can be better to have some shade on. So now I put my shade on here, but I can also have it here. And I now continue to draw this duct. I create a similar one. And now I don't want to have this automatically connect because then it's going to be an X branch. So I just draw. So when I now click, so you can see directly, and if we do like this, and now we're going for some, if I now drag this one a little bit over here. So now you can see that we have a yellow color here. So red and yellow, and you can select your colors. And let's see how visible is it if I go for hidden line. Yeah, you can see it anyway, but maybe it was a little bit clearer. So we can have this this checking online, and we can also, if you don't want to have it online, you can of course go for the settings and say, okay, I don't want to have it. Real-time flash on. But now I want to do it, then I can, okay, I go for clash checking. We have some settings here, if the whole project or okay, now I can, I don't know if you have used the BCF format. BCF zip files are normally, I don't know if you have used IFC files and Solibri model checker or Tekla BIM-site or some and kind of this software. In this, we say Solibri. BIM coordinator can use that software. They are checking, and they can, if they find something, they can create a BCF zip file and send it, and then I can just open it, and I can very fast see where my clashing. So here I can now say, okay, we have a soft clash and we have a hard clash. If I now, and this one I can have on separate screen if needed. So I can see now, I can zoom to the object. So if you take the hard clash, so you can see that it's shifting here now when I'm clicking. That is, and I can also make a note here. Maybe I'll say, okay, I'm P2 today. Move or die. No, not move or die, but I can now. So now I have. I can take a new picture here. I can export this, and if I have people that are not so, yeah, I don't know what to say, not so smart, no, not so smart, but maybe I export this, and which format do you want? Yeah, if they are not so smart, maybe they can understand PDF files, so I export this to a PDF file, and I'm typing it to my desktop. In Swedish, it's krock, clash, krock. Okay, I have used that croc earlier, so yes, create now this. So very easy to, so here we can also see in PDF format that we have one red, and it's now a soft crash and a hard crash, We have ID numbers here that you can very easily find this if you go into Revit again. So any kind of report to report the clashes out. It's not so fun to have clashes, but of course you are going to have. And of course, if I now link in electrical model, I can of course make checking to linked stuff also. I may also have this in AutoCAD side. Let's go for this, and let's say that we go with this one over here. Now I'm going to create even more clashes. And of course, if you have a 3D view here, you can see. Now I want to just copy this duct a couple of times. We go over here, and I'll take it one more time. Okay. So if I run the clash checking now, I'm going to have 3 hard clashes. How to avoid this? Yeah, of course, in normal Revit, of course, you have to make a section here and cut the duct and draw it manually above or below. We have a fancier way to do this. So I'm going to use under ventilation, I'm going to use something we call vertical crossing. I'm going to use it multiple times. And I want to make my from this point to that point on that object and that object, and I want to go for finish. And now I want to read the top elevation of that duct. And here now I have this in my model here, but of course, if I have linked in the cable trays, of course, I can read the heights from a linked file also, from the cable tray or for a pipe. I don't need to have everything in my. And let's say that, okay, I want to have now a tolerance between, I want to have 100 mils between the top of one duct and the bottom of another duct. Can I do this with 90 degrees bends? No, it says offset value is out of range because the height difference is too small, so I can't fit 2 90 degrees bends. And then MagiCAD say, okay, no, you can't do it. Can I do it with 60? Yeah, you could. Of course, if I say more distance, let's say 200 mils between, and then I try 90. No, still, if you go for 300, yeah, so something between 200 and 300, you can see the distance here between bend and bend, but it gives you a warning if you try to create something that are too tight. So very easy to now avoid this multiple times also. Okay. And of course, command is still active. So now I can go and change height or make this crossing on other objects. I don't know if I should tell you because sometimes people make a small lie. But if I go for MagiCAD piping, they also have vertical crossing. If I were a piping guy, I say I don't have this. Oh, dear ventilation guy, I don't have this crossing. You have it. You can do. You can move. And if I go for electrical, of course, they also have the crossing with the. But really, it's not. This is not. I was showing it like this on. I don't remember where he were from. Middle East, I think. He asked, "Hey, Peter, this vertical crossing, can you take it away from ventilation and piping? It's just okay if electrical guys have it." I thought, no, maybe not. So this very same thing, of course, with to avoid collisions with these tools, and also to do horizontal. If you have a column or a big vertical duct or something that you have to go around, so to go above or below, then you use the vertical. If you want to go to the left side or to the right side, then you use the horizontal crossing. Yes, a couple of common features here now. Of course, we can continue here, but I think I'm going to draw a small ventilation system now and just show you the calculations. But still here we can also go, if I want to do IFC export, I don't know how much IFC files you use in Malaysia, but here it's rather popular, or it's very popular. And IFC, both MagiCAD for AutoCAD can create IFC and MagiCAD for Revit. And IFC is if you have different CAD platforms. Maybe architects are using ArchiCAD. Maybe structural guys are using Tekla, and maybe ventilation guy using MagiCAD AutoCAD, and piping guys are using MagiCAD for Revit. 3 different CAD platforms. How to collaborate? IFC is there, can be one way, because all of these softwares can create IFCs, and in like Solibri, Tekla, BIMsite, different IFC files software, you can do all the collision checking, you can do, but of course then you use your own tool to and printouts from AutoCAD or for Revit or for ArchiCAD, or more collaboration tool to do. Spreadsheet export and import. If you want to fill in some data, then I can take this out and enter it in Excel, and then I can import it again from Excel. Running index, if you want to have unique numbering, maybe all the valves in your product, or all your smoke detectors, if they should have a unique number. So when the fire department comes to and they can see, okay, see this room, it's have been fire. I go for ventilation now here, and just draw a small ventilation network. Radius, how much time do we have? You know I can speak a lot.
That's fine. You can go ahead.
Okay, you say, well, because we are going to shift also to AutoCAD some part here.
Yeah, we can wrap up. We can wrap up the Revit. We can shift into it.
But I just show calculations here very quickly. Doesn't matter if I first put in some air terminals. Let's say that I have this air terminal, and let's say I have 45 liters from this air terminal, and directly here now I can see the red columns here are sound, and this air terminal have different sizes. So if I'm going to go for the smallest one, but if I take a bigger one now, yeah, but maybe then the diagram start at 50, so and I have 45. So of course this size is too big for this amount of air. But I can already here see that, okay, this is going to work, but I'm take a small one to just, I want to have some problems here. Okay, and of course, if I want to have other air terminal, or if I want to go for a climate beam, fan coil, or install other stuff here. But now I take just the air terminal, okay. So now it's creating the Revit family for this one, and put it in Revit family 3. So next time I install it, then the product is still here in the project, so then it's much faster. Okay, so now here I have it on my, to rotate something in Revit, you just push the space bar. If you have something with an angle, I just hold like a helicopter. I'm out flying here, and I hovering over this, and I push space bar. Then you can see if I have something round, I can hovering over, and if I continue to fly around this arc, then you can see, of course. So if you're using Revit, architects can draw in any angle. It's so easy for you to change. Okay, for this air terminal, top elevation, bottom elevation, connection. I put it out freely now. I can put it end of duct, side of duct. I can do an array. I can use a space. I want to have 2 rows, 2 columns. Do you want to put your airflow arrows out? Yes. Do we want to have an angle on them? Okay, we say 45 degrees. And I place it now here, there, like this. I'm not going to draw so much. Okay.
Maybe some space options.
Sorry.
Maybe with some space, Revit space.
Yeah. Yes. So we take now, let's say I want to place, I have a conference room there, and I want to have this, I want to use a space. And I say now, I want to have 4 rows and 4 columns maybe. And then I'm selecting a space. Or it's going to be very ventilated, I can assume. Maybe it was a little bit too much. I have to buy stocks in the stock market on this ventilation terminal manufacturer. If I don't apply this, I still now can, before maybe 4 times 4 was a little bit too much. If I go 3 by 3 and say update, okay, fewer, 2 by 2. Oh, not 32. And maybe I want to have them in any direction. Yeah, but maybe not any. Yeah, and now maybe I'm happy. Then I go for apply, and then I can continue to place in this space. Do you want to have, maybe it's too small to fit for. If I'm now starting to draw a duct, I think I place it on the bottom elevation. I'll take a supply duct. I say, let's go. I draw maybe a little bit too small. I say 160. I want to put the center of this duct at 2.6 meters. Of course, you should, of course, now check which height you have. I'm just guessing here now. I can now select which product you want to use. I'm using now this Lindab ducts, and I'm using now T branches. I want to have this product TCPU. If I'm doing a tap, I can use other. So of course, I'm drawing with real products here. So if I do also for the ducts bill of materials, I get the right amount of T's I need to buy to this project. Okay, I just go here. I'm going to have my duct, and of course, as you see, I have different options now. If I want to go with angle to horizontal, it means that I can now go with any angle. Let's say that I want to go down to 2 meters because I have to go under a beam with 45 degrees. After that, I want to continue to draw. So now we drop down to a new. With plain Revit here, I had to now, if I go and zoom this in, so here I go down and here I'm reach out for. In plain Revit, I had to go to the section to do this if I don't want to have 90 degrees bends. Now, of course, I can connect these ones one by one and draw, but of course, we have a couple of connection tools, device connection, and I want to say I want to connect all of you guys. I want you to go to this duct. And now I had just one option for this one because I had a rather small difference between. Maybe I put it, we do like this, I cancel this, and let's now raise this a little bit. We put it at 3 meters. 3,000, okay. And let's now do the device connection. Okay, U5 should go to this one. And I can also have a preview for this one. So now it's, can we say that I want to have another view template? Yeah, maybe we can, but I don't know how. Yeah, maybe it's here. If you go for that one, yes. So now it's suggesting, but I want to have, so now I have a T right and 290s and down. No, maybe I want to have 45s. Okay, so now it's going out straight and then 245 is down. No, I want to rotate the T branch. So I go for that one, for example. Because now I saved one bend because I'm rotating now the T branch 45 degrees down, and then if I want to have flex duct, I can of course say that, okay, the last meter now, I want to have a flex. So you can see also here that we have flex duct. So you can move it around. Also here in Sweden, we don't get the false ceiling so early in projects. Normally architects are delivering false ceiling really late. So of course, if you put a flex, you can move it around a little bit. But now I say, okay, no, I don't want to have flex. Take it away. You can also select if you want to have other duct, But now I say just okay. Okay, so now we have a very small, on this one I put, command is still active. Do we want to connect more air terminals? No, I'm happy with this one now. And let's say now that we put over here, I should now have a fan or air handling unit or something. So I have now used, my system is in Swedish, T1 is the name. I have drawn 1/60 duct. Now I want to do some, and I'm an engineer, so maybe I have drawn this with exactly right duct sizes. But now I'm going to buy, or I'm going to specify which air handling unit or which fan I should. So now I need to know how much pressure, how much flow do we need to have. So then I can go for some calculations. So under ventilation, I go for calculations. I go first for balancing. Maybe I have drawn this with right sizes, and here we can now put some, and I'm going to calculate this now. So it's telling me now how much pressure I need. I can put warning limits. So if it's too high, it's going to put a warning on this one. Okay, so here we now see that the start, we have 225 liters per second. Liters per second. I have in the main duct, I have the velocity of 11.2. It's a little bit too high. And the fan or air handling unit have to provide a pressure of 226.9 PA. If I now scroll down here, I didn't have any warnings. But if I check this air terminal, we go for product properties. So here we can now see the operation point. So if this point had been outside the diagram, then of course I was going to have a warning about that I can't adjust this because it's outside. But we haven't done any sound calculations yet. But this is now the internal sound that what this is going to. I haven't put in any sound from air handling unit yet. But yeah, we leave that. We say now. So this is possible to build. But maybe if you're calculating the economy, that the fan have to work maybe a little bit too hard. So I'm not super happy with this one. Yeah, I could design like this, but I think that I should change. But I know any big warnings. But of course, if I now go for sizing, if I now calculate this, I'm going to calculate the whole network. I'm going to use 1 Pascal per meter. If I had used rectangular ducts and I have false ceiling, maybe I don't have so much space. Then I can say, okay, I allow the maximum space, the height should be 400. So it can't be higher than 400, but it can be much wider, because I maybe have in the corridor, I have much space left, right, but not up and down. But now I have circular ducts. I say, okay. Okay. So here it's say now I have my old size. or to be under my 1 Pascal per meter, it's suggesting now that it should be 315 size. And then the velocity is going to drop from, was it 11.9 meter per second in this duct to 2.9. Here, if I'm not happy with this one, then I can say here, right click. Okay, MagiCAD calculate 315, but I can set here myself. I want to have a bigger or smaller. If I have forgotten to put insulation on this duct, I can also set the insulation to it. But I'm happy with this. I say just okay. And before we did the sizing, we needed to have was it 226. Let's now run the balancing again to see now with the new duct size, how can I buy a smaller fan? Yes. So now the total pressure from the fan, I need to have the 73.7. It was over 220 something. So of course, in the long run, much more economical to buy. Maybe it's a little bit more expensive to buy bigger ducts, but the energy to put into a fan less. Okay, update the model. Let's check now also the sound. We have also a couple of plugins from air handling unit manufacturers. So here I have from Flact Group. They have air handling unit software on the web, and then it's creating DXF file, and with this plugin you can convert a DXF file into a Revit family mechanical equipment. And if I connect my duct to that machine, it's going to transfer the sound data into my duct. But now we say that I haven't used that air handling unit manufacturer, but I know the sound. So now I can say, okay, over here, this is my air handling unit number 1. Now I'm just saying here and guessing. For each octave, I'm getting 60 decibel into my duct. Okay, and I say it should be here at the start. Okay, and let's now, maybe I put it here. Now I'm going for calculation, and I'm doing now my sound calculation. And first doing balancing. And here we can now see that, over here I have my sound in. I don't know why pointed there, but it's jumping there. 6 decibel coming in, and we're checking the air terminal farthest away. Okay, 41.4 decibel. Yeah, if it was discotheque playing Swedish House Mafia, doesn't matter. But if it's an office, it's too high. I think we should be under 30, at least here in Sweden. We have some rules. Okay, but is this now the sound from the fan, or is it? Yeah, if we go for product property here. No, I think this is now internal sound because this product is now a little bit too small for this amount of air. But let's say we try to remember now 41.4 and one solution to get the network in balance. Then of course it can be so that we need to install airflow dampers, like kind of this product. But now not necessarily. And then we have problem with sound. Maybe we have to put in some silencer. And I just take this. I have circular duct, so I take my circular silencer, and let's just put it on this duct. So now it's creating this silencer family. Okay, we go for 41.1. Yeah, you see my memory are so bad. So we go for sound calculations again. We are checking now if did it helped. Yes, so here we can see now the silencer, the Sorodo, how much it's taking away. But here now, yeah, it went down to type 1 decibel. So it's not an issue from the fan. It's the product itself that generates the sound. So let's say that, okay, what can I do now? Yeah, of course, we can install it now, and we can see here also that to be under 1 Pascal, it went up here to this size, 160. Maybe I want to replace all these air terminals. Maybe I tag this one. This is named TD1. It's size 100. Let's see if I now go for something we call find and replace. Because I can, of course, add a new air terminal and manually change them. But let's say now that I want to do this automatically. Okay, it's now have scanned all my projects here after, so I have used this smallest one. I want to say that I want to have, maybe I want to change product also. I want to not have a hawk. Let's go for another bird, an eagle. And let's say we take this eagle. And we say now apply. And of course, this eagle have another code. It's not TD1, it's something else. And now I have selected a bigger one. So now it's adding this product to the project and then changing them. And if it's bigger, maybe it cannot keep exactly the same position. So then it's giving us a little bit warning. But anyway, the replacement is now complete. And why didn't it update that it's now an eagle? Yeah, sorry, we need to go also for update parameters here, I think. There we go for OK. Or maybe I have the same code for it, but normally maybe you have different codes for different products. But maybe I had TD1 on both of them. Yeah, seems so. But anyway, now we have a new product, and now we can of course do the calcs again. And I'm just doing the sound calculations now to see it was 40.7 with the air terminal I used before. So just checking this, and we say okay, and we say okay, and we go scroll down. Yeah. So just to change. Now I changed the product also, but the meaning here was just the size. So the internal sound from the smaller one was too high. So now we have less. And of course, this is another. I can't. The operation point should be something in the middle, so you can turn, you can tweak you can open it more, you can close it more. We can also do like this. We update this, and let's also go for something we call a space sound calculation. And let's now, I want to have two sound sources. I want to have this one. I take now a branch copy, and I say finish, and I want to have a copy, and I want to have it here. Okay. Branch copy, because I want to have two sound sources. Normally, maybe you should have one supply, one extract. Now I have two supply here because I wanted to make the sound calculations now. And after that, I'm going to do the space sound calculation and see, because if I have two sound sources, we have to okay. So let's now run the space sound calculation. And here we can, if after the absorption time or reverberation time, yeah, if you're into sound, you know about this. And let's see now, I have some views here in my Revit that finish. that I have, what's this now? If I go up here and we say now that I want to see. So here I have now take the parameters from the space, and I have typed in now the sound data to this, and maybe was something wrong here because it says it's green, but over here it's working. We have now yellow, that's the sound. So this is, you can also by visibility see this. I can also say show the duct color after some velocity. And if I now should go for changing this duct, now it's green and fine, it's between. But if I say, okay, you should now go down from 250 to 100, then direct we have, okay, red. Yes, yes, yes. And of course, I think we should go back to AutoCAD, or what do you say, Rajesh?
Yes, yes, Peter.
How much time? Or should we take some questions?
Question that what are the other calculations that we can do? Just a brief on the other calculations,
Yes.
what we can do.
So for ventilation, we have the calculations. So we can do the sizing, pressure drop and balancing, sound calculations, and space sound. If you go for piping, then we have for heating and cooling, sizing and balancing. For domestic water, we have the sizing and balancing. We can calculate the flow for drainage. Sprinkler calculations, they are not included. You have to buy a separate license to do sprinkler calculations. For electrical, we have a project, or we are working together with Schneider. So today now in this version, you can calculate between switchboards. Already next version, you should also calculate inside the building from switchboard and out. Yeah, we have connection to Dialux also, but the light calculations are done in Dialux, but you can get the luminaries position automatically into your room or space.
Yes, thanks. Yeah, we can move to the AutoCAD.
We can move for the AutoCAD.
All our users today whoever attending this workshop will receive an e-learning certificate from on behalf of Gordon Malaysia. So you can use this certificate for your learning curves. So hope you use it. Okay.
And of course, now I spend most of the time on ventilation, but it of course exactly the same with piping, except that a cooling beam have supply and return connection, but otherwise it's kind of the same. And electrical, to draw a duct or draw a cable tray, kind of the same. Now back on the normal AutoCAD. What differ here is that, of course, here I have now my ventilation drawing, and we do the same thing, that we connect the drawing to a project file. So of course, which supply or extract air terminals do you want to have? So if I checking this one, or if I want to add a new product here, of course, we have the same thing. We have product databases with 3D geometry and information in diagrams. So we're using exactly the same databases that we use in Revit. If we go down for piping, if we're showing also, we take a product, we go for parts, I go for zone valve, of course, same thing. And if needed, you can of course also create your own symbol. Now Rajesh have created I think you have checked the Malaysian symbols library. So, but here I have, it's Friday today, so I'm a little bit happy. So I have just drawn and create the happy man here as a symbol.
Yeah, from the next release onwards, we'll release with the modules. So for now, we have to update online because we release them in between.
Okay. And of course, same thing with piping. If I just start to draw something here, now we are in AutoCAD, I have my top view here, and of course I select which kind of. I have a gold duct. I went to Dubai a couple of years ago, and they were very rich. So I just show that you can also create your own duct series, or pipe series, or cable tray series. It's all open. So I have created also my own P2 super duct. This is. No, I take now a Lindab duct here. I say size 315, and I want to start to draw over here. Which system do you want to use? And same here also, which height. I want to have the top elevation at 2.5 meter, or if I want to center elevation to at 2.5. So then I can also read heights from other objects. Okay. So now I have the duct here. And if we now go or zoom a little bit here. And of course, also here you can draw inside the building. So now I'm drawing the duct. If I want to go in the Z direction, I can right click and say Z. I can also type the capital to get this command. Let's go down to 1 meter. How do you want to go to 1 meter? I go 90 degrees right down. And let's go backwards here and draw under. Maybe over here I want to go to Z direction again, up to the same center as myself. But now I want to go 45 degrees, and I want to go to the right. And maybe I want to go like that. Okay. If I now continue to draw, in AutoCAD, you can see that circle that I have on my crosshair. It's a search circle. It's searching for MagiCAD objects. So if I click here now, it's going to find 2 ducts. So if it's find 2, then I have to help MagiCAD to select. Do you want to go with that one at 2.5 meter or that one at 1 meter? Okay, I take the bottom one and I continue to draw here. Then it's create a T branch. If I do the same thing and I'm pointing over here, at the top I have a bend, then I have a duct, and at the bottom I have also. So then I can see bend, duct, bend. Yeah, let's continue from the bend at the bottom. And if I continue from a bend, it's changing from a bend to a T. If I want to start to draw maybe from the duct, then it's suggesting the center point of that duct. Yeah, okay, fine. Very easy. If I now want to put a product, let's say, I don't know if I need any silencers or if I need, let's see if I have rather old pictures here. I take this one. I don't know if it's circular or rectangular. I just point it there. It was rectangular. If I point it here, then it's checking. Maybe it's now seems that it's going to, but it's complaining now. But you can also put stuff on stuff with an angle. Yeah, but one thing in Revit, you draw everything. You can go from first floor to 5th floor directly, and you get the shaft. In AutoCAD, we do like this. Let's say that from this point here, let's say here, I want to now go up to, and before I go up, in AutoCAD also, I define also my stories. So in project files, I have also my stories. So here I have said that my first floor, it's above the sea level, 25,000 millimeters, 25 meters above sea level. My second floor is at 28.2 meters. So it's 3.2 meters between floor and floor. So if I take my duct here and I draw it up to height level, I go in Z direction, 3.2 meters, I go 90 degrees up. And here I create something we call a connection node. Okay, and which drawing do I want to send this to? So we had the destination drawing upward. It felt that I was drawing my duct upward, and say, okay, send it to that drawing above it. So now I were at this P001, and my second floor is named V57P002. So if I go to that drawing, and I have the same, but you can't see any duct here. No, I haven't got it then. So now I go for this connect, and I want to bring it up from, and I have to go by area here. We go for select area. It should be somewhere here. Yeah. So there I have it. So, and we can still, there are two different files, but via this connection now we send information between the drawings. So I can still do the calculations. That in Revit I have everything in one file. Here I can have 10-story building, then I have 10 ventilation drawings. But the information are shared between drawings via this connection node. But as I told in Revit, if I move in Revit, then it automatically was moving. But in AutoCAD, no, I have to move it after in the drawing under. But otherwise, if we go also in AutoCAD side, let's go here, and in my ventilation drawing here now we're using XREFs, and now I have started the XREF command, and I want to XREF one piping drawing into my ventilation drawing. Or of course I could also take electrical drawing if needed. But now I can see the valve here, and what I want to do in here now, and we have also the collision check option. I have to go to right bottom, collision control. What do you want to make collision to? Yeah, of course, normally nothing, but this time we say ducts and pipes. I want to go through XREF. I say okay, and I make a square around my drawing. And I get now, why does it make collisions? Yeah, of course, if we now had zoomed over here. Oh, okay. Over here, I had now just the symbol from the valve. And then you don't understand that in real life it's a 3D valve, of course, and now the flanges are colliding with my duct, and of course the pipe seems very small, yeah, but I have rather heavy insulated. So, and how to now, yeah, of course, if I want to make one more collision, we take I copy this one, and then we go. And if I notice this when I'm drawing, of course you can avoid the collision. So if I went here, then I see, okay, now I have a collision. If I go in same height, maybe I need to go in Z direction. Maybe I want to have some tolerance, 100 millimeters, and then I want to read below the bottom off, and I read the height from the XREF. I say, okay, I want to go under with 45 degrees bends. And when I have passed it, I go in Z direction again, and maybe I go up to the same elevation of myself, and then we go up again. So of course we can do it while drawing, but if I don't want to draw, of course I can also go with also this crossing, as I showed also in Revit side, to avoid from this point to that point. I want to now go 100 millimeters, and I want to go now above the XREF pointing to the pipe. And I have a warning here, but let's say if I go with 45 degrees, yeah, then it's fine. We can also see it over here, and okay. If I want to have it tighter, of course, we can just use normal stretch command in AutoCAD. So now I just push an S for stretch, and now I'm stretching this a little bit tighter. So as you can see, also in the AutoCAD environment, of course, we have the collaboration between also pipe and duct, and of course, exactly the same if this were a cable tray. Let's go for, we do actually we take away now we unload the piping XREF. We can do the same thing here. Here I have drawn on my system supply 1, very small ventilation network. And if I do the same thing here, I go for balancing for my network, and I say it should be my network supply 1. I have many warnings. I can say mark all. And if I now, maybe I want to put out temporary text on this. I don't want to click on each and every duct. I say now, please put out automatic tag here, text with the velocity. Okay. So of course, if you are into this, you know that, okay, I have 22 meters per second, and over here I have 45.1 meters per second. Storm is 20 meters. If you see the weather forecast, if it's talking about storm, then it's 20 meters per second. And of course, over here I should have a fan or air handling unit. Now it says that it should, okay, the volume 553 meters per second. And even here I have even higher pressure than in Revit side. Here I need to have a fan bringing me 2,479 pascals to squeeze in this amount of air in this 125 size duct. And of course I do exactly the same thing. Maybe I go for sizing for my supply 1. So to be under 1 Pascal per meter, maybe I need to have a bigger size. Okay, then say 315 and 400. Let's go for balancing then, because now we have new duct areas. So we go for the balancing. Just okay. So now I have just problem with this 3. If I push out the velocity again, it was under the text. We say okay. So now it was 22 and 45. So now if I go up in size 3.5 meters and 4.4 meters, if you now see over here, right now I need to have a pressure of 55 pascals. And this product here that I have some wrong, if I see the properties for it, okay, this green area I can define myself. I can do it in Revit also, because now I'm inside the diagram, but not on the green side here. But here I can now say, if I now take, and in this case, this air terminal was too big. So if I now go down in size, and also let's see over here also, we have a warning on this one. Let's see the properties for it. Yeah, same thing here. So of course you can also do in Revit example, I had put too small air terminal, and over here I had put too big. And here we are also outside. So if I go down one size, say okay, okay, and if I now do the pressure drop calculations again, so now I don't have any warning. And of course, sound calculations are also working also here. So you can see 35. I haven't put out any dampers. How much time do we have, Rajesh? Should I go for electrical, or should we show some piping, or have we?
Yeah, we can go for more 10 minutes max.
We had, let's see what we have typed in the invitation. Reduce MEP design during, yeah, we have reduced time that you can see. Coordination, yes. Clash, yes. Integrated calculations, yes. Local symbols, yes. Bill of materials. Doesn't matter if you do it in Revit or if you do it in AutoCAD. I want to have some kind of report here. What do I want to report out? And let's say that I want to have all my air terminals. How do you want to take them out? Do you want to have it to a dialog? Maybe, or AutoCAD block, clipboard, text file, Excel file. I say AutoCAD block, and I take my current drawing here. I say okay. Now I have something small on my crosshair. I can go for one scale here and maybe scale it up a little bit so you can see it a little bit. So here I have now all my air terminals here, and of course, which columns? I have user code, manufacturer, product code, how many, if they are in a room or in a space. But of course, in the project file, I can, in my report template here, say that, okay, report template for air terminals. Let's take away the area and room number. Okay. So if we now do it again, I think we could, I do it again just to show you that now I have defined, and we take the scale, I'll say 50. So now I have less columns. So you can define this by yourself. And now it was air terminals. We can also go for a report. It's just calculating how much or whatever. But can also be that you want to do a legend, and this legend is like kind of a report, a bill of material. But the difference is that with the legend tool, we can also put pictures in it. I have now, and it's going to be rather small here also, because if you want to make it maybe easier for contractor to, have I put any pictures here? Yeah, but I have just on two of them, as you can see. Maybe we should take valves instead. Yeah, so the kind of a report but also with symbols and 3D pictures of it. So you can, because sometimes it can be hard for contractor to understand which product should I install. That they don't have any picture in their head how it's. Then we can help them to. And if I do this, and it's taking that. If I have any valves here? Yeah, there I have also. We do it. We take the legend here also. I think I have it for valve pipes. You say this one, and I take manual selection, and I say, okay, just because these small symbols, what are they meaning? Scale 50. Now it was just the same. Of course, so the legend tool is that you can have graphics also in the report. Then it's just numbers and text. And of course, exactly the same also in AutoCAD or in electrical side. If you want to have kind of the same, yeah. Why do I go for one electrical drawing? I go maybe over here. Here I have some spaces, and I have put out some luminaries. And maybe I want to have the kind of the same in electrical side also. So of course, then we have also the legend also here. Let's say that I want to use this one, and of course this template coming from the project file. I make a manual selection. I say just okay, and we say I want to have it just this area. So on my crosshair now it's going to be something small again. I just scale it 50 times to get a little bit bigger. Scale 50. So of course also here you can make it a little bit easier for contractor to understand what symbol, what kind of product or that symbol representing in the real life then. And we have product databases also on electrical side. For example, if I now want to draw a socket, for example, if I want to add a new product here, then we add it to the project file, and I go for select here, and let's go for ABB. So here we have different kinds of sockets. Maybe the electric guys are not the guys that are screaming that, oh, we need to have more 3D sockets. No, but luminaries, they are, of course, big stuff they are interested in. But it's working exactly the same. If we go for Schneider, let's see what kind of sockets do they have. Yeah. But if you can't find a product, then we have a tool called MagiCAD Create. Let's I just go for Create. Let's say that I need a luminary that doesn't exist. So here on my desktop, I have a database. It's called Modo. This is my ice hockey team in my hometown. Let's say that for electrical, I want to create a new luminary as a new product. Then I can select from our generic library. I can say now that I don't know which one I should use. Say this downlight. Say, do I have any? So I can use a pre-made shape. No, I want to have some more fun. Maybe luminous was bad example. Oh, let's take the emergency. This one. We take that one. Okay. So this is now, and now I can go and say that different luminaries have then how many different values can you change? On this, it was just 3 of them. So I say 500. It's going to be 500 and 500. Rather boring, but anyway. So if you now, maybe that one was too much. 200. And we say 1,000. Yeah, this is now my new emergency exit. It should now be, but of course now I'm just guessing here now. I don't know in real life. Maybe you don't have any emergency exit lights that are 1 meter wide or long, but yeah, just for so now we are happy with this one. So this is now my own product. So if I now go for, and I want to draw my luminaries, and I want to add now a new luminary to my project. Okay, then we select a symbol for this one. Let's take a Swedish symbol for emergency exit. And then I want to have a product. But this luminaries database you see here, they are now on the cloud, updating all the time. But I had mine local now, and I had it on my desktop. So I browse for my desktop now, and I go for browser. And here I have my Modo database, and here I have now my emergency exit 3D object that are 1 meter wide. I say now select. And of course, this MagiCAD Create, if you're creating a valve or air terminal, you can of course also enter all the diagrams. So if you can't find that manufacturer and you want to, you can of course with this free software MagiCAD create your own. Yes. And of course, I can continue. I think you can notice that I can talk for forever here, but we don't have all day, and maybe you have Friday evening coming soon here. Here now it's 10 minutes to 11, so I have soon lunch. I still have snow in my yard. Rajesh,
Yes.
do you have any more questions, or should we wrap up? Or
yeah, thanks, Peter. there are people asking about the bill of material, so we already look at it. So yeah, thanks a lot. Thanks for staying with us. So make sure we will get back to all the attendees will receive a certificate, e-learning certificate soon from the on behalf of Golden Malaysia. So thanks for tuning in. Have a good day. If you have any questions, please do ask now, and we will try to. Yeah, there's a question here. When we can have another class? Soon, maybe we can have a physical class if the MCO is lifted, the movement control order, the outbreak is clear. So maybe we can. We usually conduct the workshops with hands-on experience. So unfortunately, during this outbreak, we couldn't do that. So maybe we will update you with new classes. Thanks,